Hello, everybody. And today this is Mr. Greer. Today we're going to be dividing decimals by whole numbers. All right, and that's what we're going to discuss is dividing using decimals. Hopefully in this video we're going to get through dividing using whole numbers, but then I also would like to do dividing decimals by decimals. It's a little trickier, as you can see, a couple of more steps, but we will get through it together. All right. So the first thing I do want you to understand is that when you see division problems, they might be written in multiple ways. If you look at example 1, you see here that we have 9 and 32 hundredths divided by 4. This means the same thing, 9 and 32 hundredths divided by 4. But there's some other ways, right? We know about this way. Okay, and you've seen this way. But this is another way of doing it. It's a fraction. 9 and 32 hundredths divided by 4. And here's a fancy way. This is how I kind of write when I'm trying to save space when I'm writing fractions. But it's the same fraction. 9 and 32 hundredths divided by 4. This little slant is the same thing as this here. It's the divisor. It's the same thing. It's just a fancier way of writing it. And it's also a way of writing it so it's all on one row instead of you having to have the 2 rows here. For the sake of class, I never write my fractions this way only because it's messy, it doesn't look good, especially when you're trying to multiply and such. I always write my fractions this way. This is just when you're just trying to get some numbers out there. Okay, so let's do the division for this problem here. We see the answer already, right? But let's go ahead and do the division for the problem. And so all this is on page 88, and it's example 1. So example 1 is 9 and 32 hundredths divided by 4. All right? It's magic. There we have it, okay? So let me rewrite this so that I can actually work the problem. So 9 and 32 hundredths, and when I say divide by 4, right? Because the second number goes outside the house, or the bottom number goes outside of the house, right? So here we have it, 9 and 32 hundredths divided by 4. And then we go ahead and do our normal division. But maybe the first thing we might want to do is put this decimal point where it needs to go. In a division problem, when the denominator is not a decimal, all you do is take the decimal point and you move it straight up. See that? So I took the decimal point and I moved it straight up. So now that decimal point is right where it belongs. Now I can do my division. 4 goes into 9 2 times. 4 times 2 is 8. And then I can do my subtraction. 9 minus 8 is 1. We bring the 3 down. So now we have, how many times can 4 go into 13? 4 can go into 13 3 times. 4 times 3 is 12. Do my subtraction. 3 minus 2 is 1. And 1 minus 1 is 0. And then I'm going to bring down my 2. 4 goes into 12 3 times. 4 times 3 is 12. Do my subtraction, 0. So our answer is 2 and 33 hundredths. So that's the main trick about dividing using decimals, dividing decimals by whole numbers. The main trick is, first of all, writing it correctly So getting it from this point to this point, right? Or getting it from this point to this point. Getting it from this point to this point. You've got to be able to get your division problem to look like this, okay? And as you see in the first couple of sections in page 88, it's already laid out for you, right? They're already laid out for you properly. But then as we go further, they don't lay it out for you properly anymore. Now you have to rewrite each problem and then divide. So you've got to transform it from looking this way to looking this way, okay? And I'm going to do a few of these with you so that you understand how that transformation takes place. And then when we get even further, you got to get it from looking like this to looking like this, all right? Now, believe it or not, we've already practiced this skill many times whenever we turned an improper fraction into a mixed number. We were actually dividing, right? We were turning something that looks like this into a division problem. And so we already know how to do it. Sorry, I'm trying to get the screen back to normal here. So we've already worked with these and turned them into division problems, but now we're doing it with decimals, and it's not much different, okay? Let's take a look at example 2. Now, example 2, it says you may have to put a 0 in the quotient as a decimal placeholder. Let's see what that means. Let's take a look at this problem. 222 thousandths. So let's rewrite that. Example 2. 222 thousandths divided by 6. So there we are, right? So 222 thousandths divided by 6. All right, because remember that second number, when it's written this way, the second number goes outside the house, first number goes inside the house. 222 thousandths divided by 6. Now it's set up. Now we can get to work. But I forgot to do something. Oh, that darn decimal. I'm going to move that decimal up automatically. That way I know it's always going to be in its proper place. So now we can start doing some work here. 6 can't go into zeros, so I'm not going to worry about it. If you want, you could say 6 times 0 is 0, all right, and leave it at that. Okay, but you really don't need to do anything here. Let's look at this 2. Can 6 go into 2? It cannot. So when you are moving to the right side of a decimal, you can put zeros in as placeholders, right? So since we can't, there's nothing I can multiply times 6 that's going to make 6 go into 2. I'm going to go ahead and put a 0 here as well, all right? So now let's look at 6 goes in, how many times 6 can go into 22. Oh, that can work. 6 can go into 22 3 times. 6 times 3 is 18. Do my subtraction, right? So 18, 19, 20, 21, 22. So 4 times. So 22 minus 18 is 4. I'm going to bring down my 2. So 6 times something is going to go in, is going to equal 42, right? That's a 2. So let's take a look at what it would be. Well, 6 times 6 is 36. That's not big enough. 6 times 8 is 48. That's too big. It'd be 6 times 7. 6 times 7 is 42 exactly. Do my subtraction. There we go. Your answer is 37 thousandths. So this is what they meant when they said that zeros can be a placeholder. They use this word quotient. All a quotient is, it's the answer of a division problem is called your quotient. So if you look over here, what we did is just, they did the same thing we did. 6 can't go into 0, so they put the 0 there, right? 6 can't go into 2, and so we put a 0 up here as well. Because when you're after the decimal, just like when we were multiplying, we used the decimal and we could add zeros after the decimal, you can do the same thing up here. So after the decimal, we're like, nothing can go into 2, so we can put a 0 here. The 0 holds the place. And then we said, okay, well, if 6 can't go into 2, can 6 go into 22? Yes, it could. 6 goes into 22 3 times. And of course, 6 times 3 is 18. And then we went ahead and did the rest of all this work that we just did here. All right. So you're going to come across problems like that, where the number is not going to go into the first number, but it could go into the rest of them. Okay. And 0 can be used as a placeholder to help you with that. So dividing, it takes time, it takes up some space, and there's really no way around it. I would say use your multiplication strips. I would say use a calculator if you need to help you out to get the answers correct here with some of these divisions, okay? So you can get comfortable with the work. So let's take a look on page 88. Oh man, it's still doing that out of focus thing. Hang on, trying to get it to focus. There we go. Let's look at number 1. So number 1 on page 88 is 13 8/10 divided by 6. 13 8/10 divided by 6. That's our problem. All right. So let's work on this. So once again, we're dividing by a whole number, which means there's no decimal here, there's a decimal here, right? So we need to move that decimal point up. So I know it's in the right place. And now I can get to work. 6 can't go into 0. 6 can't go into 1. But 6 can go into 13. 6 can go into 13 2 times. 6 times 2 is 12. Do my subtraction. I'm going to bring the 8 down. And then 6 can fit into 18 3 times. 6 times 3 is 18. So our answer is 2 3/10 for the first problem in row 1. Let's take a look at the next problem in row 1. And this is 70 2/10 divided by 9. All right. 70 2/10 divided by 9. First thing I want to do is take care of the decimals. So let's move my decimal up. So I know it's in the right place. And now I can get to work. 9 can't fit into 7. Just can't happen. But I'm pretty sure 9 can fit into 70, right? 9 goes into 70 how many times? Well, let's see how many times. If you look at your times table, you can see that 9 times 6 is 54. Not quite big enough. 9 times 7 is 63. 9 times 8 is 72. 72 is too big, so let's go back to 9 times 7, right? Which would be 63. So 9 can fit into 70 7 times, because 9 times 7 is 63. Then I'll do my subtraction, right? And here, if you want, you can borrow, right? 10 minus 3 is 7, and 6 minus 6 is 0. And we can bring down a 2. And 9 into 72. Oh, well, we already found the number for that, didn't we? We said that 9 times 8 equals 72. So 9 can go into 72 8 times evenly. 9 times 8 is 72. Do my subtraction. Your answer is 7 8/10. Let's take a look at the next one. Page 88, it's the third problem over. And that problem is 384 thousandths divided by 4. 384 thousandths divided by 4. So let's work on this, okay? What's the first thing you want to do? You want to move that decimal up and put it where it belongs. That way you know it's where it should be. All right, so 4 can't go into 0. You can put a 0 here if it makes you feel better. Okay. Can 4 go into 3? No, 4 can't fit into 3. So now we need to put a 0 here as that placeholder. Because it's after the decimal, we need to put a 0 here for the placeholder. Can 4 go into 38? Ah, there's something we can work with, right? So let's think about this. We know 4 times 5 is 20. We need to go bigger than that, right? You could say 4 times 7, that's 28. That's pretty good. Can we go any higher? 4 times 8 is 32. 4 times 9 is 36. 4 times 10 is 40. So 40, that's too high. So we need to go down one, right? So 4 times 9 is 36. That's enough. So we know that 4 can go into 38 9 times. 4 times 9 is 36. Do my subtraction. 38 minus 36 is 2. Bring down the 4. How many times can 4 go into 24? Hopefully you're over there thinking, or you've got a calculator, or you're using your multiplication table or multiplication strip, and you'll know that 4 times 6 is 24. 4 times 6 is 24. Do my subtraction. Ah, that's perfect. Your answer is 96 thousandths. Because that 0 held its place, and so the 96 keeps the value of the thousandths, right? Because the 6 is in the thousandths place. Let's take a look at the very last one. So page 88, the very last one on row 1. And that is 57 75 hundredths divided by 7. 57 75 hundredths divided by 7. I keep repeating it like this so that you can understand where all these numbers are going to go. Because when we start working on row 3, we're going to have to do some moving around, right? So that's why I keep saying it that way. I know I sound like a broken record, but trust me, it's going to help in a little bit. All right, so let's take a look at this here. What's the first thing I'm going to do? If you said move that decimals, you are 100% correct. So move the decimal up. Now I know that looks like a heart, a weird heart, doesn't it? Change that to an emo decimal. There we go. It's sort of decimal. Okay, good. So now we have moved the decimal up. Now we can get to work. 7 can't go into 5. But I'm sure 7 can go into 57. And if you look at your multiplication tables or charts, use your calculator to help you out, you'll know that 7 times 8 is 56. So we can use 8 here. 7 times 8 is 56. Do my subtraction. Then I'm going to bring down the 7. 7 can fit into 17 2 times. Because 7 times 3 is 21. That's too big. But 7 times 2 is 14. So that's perfect. Do my subtraction. Right? 17 minus 14 is 3. And then I'm going to bring down the 5. And hopefully, we've always said if it's a 0 or a 5, that it's going to be a multiple of the number 5, right? So just so happens that 7 times 5 equals 35. And it's perfect. Your answer is 8 25 hundredths. So that was the top 4. And that was all the 4s, the 4 ones on row 1. That was all 4 of them, okay? So I want you guys to work on row 2 on your own. I want you to work on those as homework, part of your homework, okay? Now let's move down here to the ones that aren't set up for us yet, okay? Once again, we're on page 88. And the first one we'll look at as number 3. The first one in row 3. 76 8/10 divided by 16. Here we go. We got to write it so that it looks like one of these, right? So we can do the problem. So let's go ahead and do that. So 76 8/10 divided by 16. Now, this looks like something we can work with. The first thing we're going to do, as always, is move that decimal up. Okay. And now the decimal point's been moved up, we can get to work. So 16, that's a big number. It might be hard for you to figure out what to work with. You could use a calculator, you could use a times table if you have one. All right, just see what you got. So 16 going into 76. I'm going to guess maybe at least 5 times. So 16 times 5, that equals 80. It's a little too much. So definitely I'm sure 4 is going to work. And that's 64. So that's going to work out just fine. So 16 can go into 76 4 times. 16 times 4 is 64. Do my subtraction. 6 minus 4 is 2. 7 minus 6 is 1. I'm going to bring down the 8. So you're looking at, man, 128 and 16. These are big numbers. But as I've always said, no matter how big the number is, the steps stay the same. Never get intimidated by the size of the numbers. The steps will always and forever stay the same. So 16 going into 128. Well, let's go big with it, right? We know it's going to be smaller than 10, right? Because 16 times 10 will be 160. So let's try 16 times 9. See if that helps us out. That's 144, a little too big. Let's try 16 times 8. Ah, beautiful. It's 8. 16 times 8 is 128. Do my subtraction. And there we go. All right. I don't know if you guys remember my little trick about the numbers 8 and 16, but remember the Nintendo was 8-bit, the Super Nintendo was 16-bit, right? And then you had the PlayStation's 32-bit, which means 16 times 3 is 32. The Nintendo 64 was 64-bit. and then doubling 64 will get you 128. So that's how I always remember that stuff. I know it's nerdy, but it helps me out here. Okay. So the next one I want to do, and the last one I want to do with you guys, is going to be on the fourth row. Okay. The fourth row. Page 88, row 4, the first one. And this is 9 516 thousandths divided by 52. 9 516 thousandths divided by 52. We need to write it so we can work it, okay? So we'll start off 9 516 thousandths, right? Divided by 52. As you remember, the denominator, the bottom number, always goes on the outside of the house. The numerator, the top number, is always nice and cozy on the inside of the house. Because that 52, I guess they didn't do the dishes or something because they've been put out. All right, so now we can work, right? The first thing I want to do is move that decimal. You've got to move that decimal. Now I can get to work. 52 into 95. Well, if you know anything about the number 50, 50 times 2 is 100. So that's not going to work. So it's looking like we're going to have to use the number 1. Okay? Because 52 can't go into 9, right? So you can put a 0 here, make you feel better. Do our subtraction. 5 minus 2 is 3. 9 minus 5 is 4. I'm going to bring down my 1. 431. Big numbers, right? No matter how big the number is, the steps stay the same. So use your handy-dandy calculator, multiplication table, whatever you need. 431. I'm thinking I could use the number 4. So 52 times 4, let's see. That's 208. I was wrong. Let's go bigger. Let's try 8. 52 times 8. 416. Could I go any bigger than that? 52 times 9. 468. Too much. So we're going to stick with the 52 times 8. All right? So we're going to use the 8. 52 times 8 equals 416. Do my subtraction. Got to do some borrowing though, don't I? 6 minus 11 is 11 minus 6 is 5, right? 2 minus 1 is 1. And then 4 minus 4 is nothing, right? I'm going to bring down the 6. Okay. Oh boy. Let's see how this goes. Now looking at this, hopefully some of you can already tell what number goes into 52. How many times 52 can go into 156? I'm guessing it's 3 if I'm looking at this. But let's see. I'm going to use my handy-dandy calculator. 52 times 3. I was correct, 156. And there we go. Your answer is 183 thousandths. So I'd also like you guys for homework to go ahead and finish page 88. Now we've done all of row 1 together. So I need you to do row 2. And then I'd also like you to work on the rest of rows 3 and 4. So that's 1, 2, 3, 4, 5, 6 more problems. And I think later on during our meeting today, we'll go over dividing decimals by decimals and also any other questions that you might have. Okay? So I'm going to make a video about dividing decimals by decimals in a little bit. It's going to be a little shorter, but at least it'll be something you can look at to reference as we go deeper into it during our meeting today. Thank you.